Let's find inverse matrices. Example 2, finding the inverse of a matrix. So we're finding the inverse of A equals 1, 4, -1, and -3. So to find the inverse of A, we're going to solve AX equals I for X. Okay, so let's write that. So A, we know this is A. A is 1, 4, -1, -3. And then X is going to be this. X is X11, so that's the first row, first column, remember that. X12, X21, and X22. And so that is going to equal the identity 1, 0, 0, 1. Okay, so this is the identity, so AXI. So this is the matrix equation, and then if we write this, let's multiply. So we need to multiply A times X. So this is 1 times X11 plus 4 times X21. Then we have 1 times X12 plus 4 times X22. Then the next line, we have -1 times X11 plus -3 times X21, and then -1 times X12, and then -3 times X22. And that's going to equal 1, 0, 0, 1. So we're going to equate the corresponding entries to get the system of linear equations. So what I mean with that, and we're going to set this up one time, and then you'll be able probably to do it without this. So we're going to set that equal to that 1, this equal to the 0, and then this equal to here, and so forth. So this is going to look like, so I'm going to write it as a system first. X11 plus 4X21, and then -X11 minus 3X21. Sorry, this top one equals 1, this one equals 0. Then this other system is X12 plus 4X22, and then -X12 minus 3X22 here. And this top one again equals 0, and this one equals 1. So then we're going to use Gauss Jordan elimination in order to solve. So let's set that up. So this is 1, 4, 1, -1, -3, 0 on this side. And here we have 1, 4, 0, -1, -3, and 1. So let's solve for the left. So what we're going to do is we can go ahead and just add row 1 and row 2 together to get a new row 2. So this is 0, 1, and 1, so I added row 1 plus row 2 here. Then next what I'm going to do is I'm going to multiply this by -4. So that's going to be -4, -4, and I'm going to add it to the row above it. So I get 1, 0, -3, and then the bottom one stays the same, 0, 1, 1. So I got that by -4 row 2 plus row 1. Then let's do the right side. So, well, we can write the answer. So we can say that X11 equals -3, that's the answer here, and X12 equals 1. Okay, let's do this right side. So we have 1. We're going to add these together, so the 2 rows together, and then get a new row 2. So this is 0, 1, and 1. Then we're going to multiply the bottom again by -4. Okay, how did I get this? Row 1 plus row 2. So adding the rows together, I get 1, -4, -4, 0, and -4. And then the bottom is 0, 1, 1. So what that tells us is X21 equals -4, and X22 equals 1. So the identity matrix is -3, -4, 1, 1. We can also do a check, and I'm sure you can figure out how we do the check. So this is our A inverse. So what you do is you multiply A, and then times the inverse, and you should get the identity matrix. Okay, so just to show you, do 1, 4, -1, -3, and you multiply it to -3, -4, 1, and 1 here. Okay, and then you should get 1, 0, 0, 1 after you multiply everything out. Now find the inverse of A here. A equals 1, -2, -1, 3. So try this out. So if you try this out, you find the inverse to be 3, 2, 1, 1. And then, of course, you can always check to see if it is true by doing A times the inverse of A, and you should get the identity matrix. And also the same one, A inverse times A, still get the identity there.